We now move on to chapter 8, which is on physics of matter. So I can split this chapter here to 3 sections, and this series of video here is on section 1, which is on deformation of solid. So in this chapter, we'll be learning about solids which are being deformed, or we can say this solid experience a change in their shape due to some kind of stress being applied on them. Okay, so without further ado, let's talk about the two important parameters when we talk about deformation of solid, which is stress and strain. So stress, we can represent it with a symbol of sigma. Okay, it's the force acting per unit cross-sectional area. So it's force per unit area, so you can deduce the equation for stress, sigma, should be equals to force divided by area. Okay, so let's understand this equation with greater details. Okay, F here is a force acting perpendicular to the cross-sectional area of a specimen. So a specimen is the object or the solid that is being deformed. So let's say if we have this cylinder here represents our specimen. And when we talk about this force over here, this force must be acting perpendicular to the cross-sectional area. So if we assume this surface here to be our cross-sectional area, or this one, or any circular shape area that we have as our cross-section area, then the force will have to be applied perpendicular to the cross-section area. So there's two ways of applying force perpendicular to the cross-section area. One is if you stretch the specimen by pulling both ends, you are stretching it with a force F. You can see that this force here must be perpendicular to the cross-sectional area. So this is one way of exerting a force on the specimen. And we call this kind of test being a tensile test. We learned about tension in previous chapter. Tension is basically a rope being stretched tight. Okay, so tensile test in this case is also the specimen being stretched. Okay, you apply a force to stretch the specimen. Okay, another way of applying a force is to press on the object from both ends. You have a specimen, you press it on both ends with a force of F. In this case, it's the opposite of a tensile test. We call this as a compressive test, because what we are doing here is we are compressing the specimen over here. So these are two ways to apply a force perpendicular to the cross-sectional area of the specimen. And of course, to make it clear, where is our specimen cross-sectional area? The cross-sectional area is this circular area for the specimen. So if your specimen, you press like this will be your cross-sectional area. If this is your specimen and you press like this will be your cross-sectional area. Okay, you have to be very clear where is the force being exerted, where is the cross-sectional area. Only you are able to determine this value, which is force per unit area, stress. Okay, the unit here, force it's Newton, area it's meter square. So force Newton, area meter square, divide, you get Newton per meter square. So we can say that the unit is Newton per meter square, and it's equivalent to Pascal. So 1 Newton per meter square is equivalent to 1 Pascal. So these units are interchangeable. Okay, during this test over here, we also assume that the area to be constant throughout the test. So usually if you imagine, if you're stretching something, the thing will be thinner and thinner. Whereas if you compress something, the thing should get thicker and thicker if you compress it, because you put it into a small area, it should get thicker. You stretch it over a larger length, so you get thinner, right? Okay, but in this situation, when we're talking about deformation of solid, we're going to assume that the area is constant throughout the test. Okay, there's a reason behind it. It's not exactly true, but we're assuming it. Okay, so this is all you need to know regarding our syllabus for stress. Let's move on to strain. Okay, strain is represented by the symbol which is epsilon over here. This symbol here represents epsilon. So it's the ratio of the change of length to the original length. So ratio means that there's a divide in your equation. So your change of length is represented by delta L, whereas original length is represented by L naught. Okay, so again, let's come back to original length of the specimen, L naught. We have our tensile test and compressive test. So initially, this is the original length of our specimen. So this length over here, L naught, is the original length of the specimen. Nothing too special about it. For tensile test, we are going to elongate it, because we are stretching it. We are going to elongate it. So as a result, your specimen here will experience an increase in length, right? So this increase in length here will be the change of length. Okay, for compressive test, you're pressing on it, you're making it shorter. So if you're making it shorter, so it should experience a decrease in length for the specimen over here. So this change in length over here is what we call as delta L. We don't need to consider whether it's stretched or it's compressed to say whether it's positive or negative. We don't need to care about what kind of change is it. We just need to know how much change is it. There's no sign. We don't need to assign any positive or negative to this value over here. So that is the change in length of the specimen due to the stress applied. Again, there's no positive or negative sign for your change of length. You don't need to care whether it's compressive or it's elongate. Okay, so you know that delta L here is a change of length, so the unit should be in meter or in cm, whatever you prefer. Okay, but if you're keeping the unit consistent, L0 here should have the same unit as the change of length, because both of them are length measurement. So if you take length measurement divided by length measurement, technically you should get a dimensionless value or dimensionless unit for your strain. So strain here has no unit, but stress here has a unit of Newton per meter square. So this is what you need to be clear about. So that's the idea, and that's the concept that you need to know regarding stress and strain.